Hello, my name is Afer Olkay. Welcome to my question answering video for experiment 4 and 5. For the first questions, we were asked what is the IP rating that we saw on the DC machine. The IP rating is the rate of how well the motor is protected from intake of unwanted solids and liquids. It consists of two digits, which first one can be range from 0 to 7 and the second one can be range from 0 to 8. The first number represents how well it is protected from solids, and the second one represents how well it is protected from liquids. The 0 represents the no protection rate, whereas the highest number 7 and 8 means that it is fully protected from unwanted solids and liquids. For the question 2, we saw that even though we had no field current, we induced some voltage when we gave a rotational speed to the machine. This is because the nature of ferromagnetic core. When a ferromagnetic core is induced formerly by a by any magnetic field, it's if it is magnetic ferromagnetic, its magnetic lines are tends to stay the same even though no external field is applied, and this phenomenon called is residual magnetic field. And this is the reason why we had some induced voltage, because there was some little small amount of magnetic field in the air gap. For the question 3, we were asked to explain even though we decrease the field current, we saw that the rotational speed was increased. The reason for this is, let's look at the equations. We know that EA is the result of KA, the flux, and the rotational speed. When we decrease the field current, we saw that we can understand that the flux is decreased. And when the flux is decreased, I should also add that the armature constant is always the same. In order to have a EA to be constant, we have to have the magnetic rotational speed to be higher. And why is the EA is constant? Because we also have this condition: the armature current is the same, and if the armature current is the same, the VA is also constant. Therefore, EA has to be constant, and this is why the rotational speed increases if the field current is decreased. For the last questions, we were asked to explain why when we increase the rotational speed, we also had we saw a increase in the VA. This is because, again, let's look at the equations. We know that armature constant is constant, like its name, and we didn't touch anything about KF or field current. Therefore, this is constant as well, and we increased the rotational speed. Therefore, this caused the increase in the armature voltage. And we also know that we kept torque constant. Therefore, we also know these are constant. The armature current has to be constant. With this assessments, we can see that we know EA is increased and current multiplied by resistance is constant. Therefore, this causes VA to be higher. Therefore, when we increase the rotational speed, VA is also increased. Thank you for listening to me.